Hi, this is Don Crawley from SoundTraining.net. Today I'm going to show you how to configure a site-to-site VPN using two Cisco ASA security appliances. You use a site-to-site VPN when you have, say, two offices in different locations and you want an always-on connection between them. In the past you might have leased a dedicated line, but today you usually just set up a VPN link, such as what you're presently seeing on screen. This video is based on Chapter 8 in my book, The Accidental Administrator, Cisco ASA Security Appliance Step-by-Step Configuration Guide, 2nd edition. You can follow along by purchasing a copy at www.soundtraining.net/bookstore. I also have a free document available for you to download with the actual configs and companion network diagram at www.soundtraining.net/L2L-VPN-configs. It does require registration, but there's no cost. I'm going to use the network diagram you're seeing now for the following configuration. You might want to pause the video for a moment and study the diagram. I'll be working on ASA 01. ASA 02 has already been configured. Okay, so let's go ahead and get started. Now we've already configured the other firewall on the other end of the connection, so we're just going to be dealing with this one. But let's start a ping, a continuous ping to the other PC. This PC is located on the inside subnet on the other side of the other firewall. And by setting a continuous ping, we'll be able to see as soon as the tunnel comes up and we have successfully configured the VPN tunnel. So we'll do ping 192.168.102.6 with a -T. That makes it a continuous ping, as you probably know, and as you can expect, the ping will fail because we don't have the tunnel set up yet. So now let's go to our ASA and we'll start configuring the tunnel. First of all, we need to go into configuration mode, so config T, and now we're going to enable ISACamp on the outside interface. That ISACamp is the handshake part of the configuration. So we'll do crypto ISACamp enable outside. Now we're going to do a couple of preliminary steps. First of all, we're going to set up our network objects to identify our inside subnet and our partner's inside subnet, our local and the remote inside subnet. We'll also configure an access control list to identify and permit the traffic flows from our inside subnet to the remote inside subnet, and we're going to configure the tunnel groups as well. So let's start by configuring the network objects. Object network net-local. Net-local is just a text string that I use. It's a name. I prefer to give them descriptive names so that I can look at it in a configuration later and immediately know what it's all about. We'll do subnet, and we'll put in our subnet, which is 192.168.101.0. We have to put a mask with it, 255.255.255.0. Next we'll do the remote subnet. This is the subnet on the inside network connected to the other firewall. So object network net-remote, again just a text string, a name that I chose to give it, and subnet 192.168.102.0 with the same 24-bit mask. And there it is. We'll type exit just to come out of it. Not necessary for the configuration, but it does make it easier to see as we go through the configs. Next, we've got to build our access control list. This access control list is used to identify the traffic flows, identify and permit the traffic flows from our inside subnet to our partner's inside subnet. If you're not familiar with Cisco ASA access control list syntax, how they're built, please take a look at our video. We have another video on our YouTube channel or on our website at www.soundtraining.net on how to do that. Pause this one, go watch that one, then come back to this one. So here we go with setting up the access control list. Access-list outside _1 crypto map permit IP traffic from the network identified in object net-local going to the destination identified in object net-remote. And that's our access control list. Next we've got to set up the tunnel group. One thing to think about. Access control lists are inside to inside, so that is our inside network to our partner's inside network. Tunnel groups and peers are outside to outside. So we're going to be connecting to our peers outside interface and referencing our peers outside interface. You'll see what I mean as we go through it. So let's go ahead and set up the tunnel group. Tunnel-group 192.168.0.12. That is our peers outside address. Then we have to specify the type of IPsec tunnel. So it's type IPsec-L2L. I know it looks like 121. You'd think they could have used capital L's maybe. It stands for LAN to LAN, but just bear that in mind. Don't let the appearance fool you. It is L2L. Next we have to set up the attributes for the tunnel. So tunnel-group 192.168.0.12 IPsec attributes. Notice what I did there. If you're not familiar with this, it's pretty cool. You can do command line completion just like on Unix and Linux systems by typing enough of the command that it's unique and then hitting the tab key, and that'll keep you from mistyping, fat fingering like I do. Go ahead and hit enter. Notice the prompt changes. Now we can enter our pre-shared key, which is pass1234. I hope in production, of course, you'll use something considerably more robust than that. But bear in mind that whatever you do in setting up the tunnel groups, it's got to match on both ends of the connection. So your key has to match. The IP addresses have to be the peer's outside address. You don't have to set keep alives, but we'll go ahead and do it anyway, just in case you might want to. If you have weird network conditions or something, you may want to vary this, but we'll do isacamp keep alive threshold 10 retry 2. That's the default setting, and then type exit. So now we've done the preliminary work. Now it's time to set up phase 1. Phase 1 is the handshake. That is the key exchange. Phase 2 is actually setting up the tunnels. So we'll start by setting up the handshake, the key exchange. We'll be doing ISAKMP settings here. That's Internet Security Association Key Management Protocol, which is roughly synonymous with IKE, Internet Key Exchange. So here we go. Crypto, ISAKMP, policy 10, authentication, pre-share. Now, let me explain this. Crypto means we're invoking cryptographic services. ISAKMP means that we're doing the phase 1 stuff. Policy 10, that's just identifying the policy, and it could be any number between 1 and 65,534 inclusive. It's just a label saying that this is a grouping of settings. And the authentication says how are we going to authenticate each other, and we're going to do it with a pre-shared key, which we already configured with the tunnel group. Next, we need to set our encryption. So we'll do crypto ISAKMP policy 10 encrypt 3des. A lot of people are starting to use AES, but this is the default. 3des is. Next, we're going to set the hashing algorithm that we'll use, and we'll use SHA, secure hash algorithm, crypto ISAKMP policy 10 hash SHA. MD5 is also supported. SHA supports a slightly longer key length, so it's a little more robust. And finally, the Diffie-Hellman group, which is actually used for the key exchange. So crypto ISAKMP policy 10 group 2. Most important thing is these settings have to match on both ends. Last thing we're going to do is specify the key lifetime. Crypto ISAKMP policy 10 lifetime 86,400 seconds or 1 day. Just make sure they match on both ends of the connection. That's our phase 1 stuff. Now let's do the phase 2, setting up the tunnel. This time, instead of using ISAKMP, we're going to use IPsec. So crypto IPsec transform set ESP-3des-SHA. That is simply a text string identifying the transform set, naming it. You could call it Billy Bob or whatever you want to. I again prefer to use descriptive names. So now we'll specify what we're going to use, the different technologies that we'll use. We'll use ESP, that is the encapsulating security payload. which is really the only one you can use. Authentication header is also used in IPsec, but it doesn't work with NAT for reasons that I'm not going to get into here. It's covered in the book if you want to know more about it, but we'll just use ESP, and we'll use it with 3DES. So 3DES. And then our hashing message authentication code will be SHA, so ESP SHA HMAC. That's our transform set, which we will reference later on. Now let's map the crypto map to the access control list. So crypto map outside underscore map 1 match address outside underscore 1 underscore crypto map. Now that crypto map outside map, that means the outside map is the name of the crypto map. 1 is just a sequence number within the crypto map. And if you don't specify a different one, it simply appends each line to the previous line. Match address outside underscore 1 underscore crypto map tells it to use the access control list that we configured right up here, as you'll recall from earlier. Alright, so next we're going to tell it to use perfect forwarding secrecy, which randomizes TCP sequence numbers, adding another layer of security. So crypto map outside underscore map 1 set PFS group 1. Notice there's no space between group and 1, and it will error if you put a space there. Next, we're going to identify our peer at the other end of the connection. You thought we'd already done that with the tunnel group, but we also have to do it with the crypto map. So crypto map outside underscore map 1 set peer 192.168.0.12. That is our peer. That's something that's already configured. Next, we're going to go in and tell the crypto map which transform set to use. So we're going to reference the transform set that we configured earlier, one we did right here. You'll see what I mean in just a moment. So let's do crypto map outside underscore map 1 set transform set ESP-3DES-SHA. And finally, we're going to apply the crypto map to the outside interface with the command crypto map outside underscore map interface outside. So that's our phase 2 configuration. We have 2 more steps. We have to configure NAT, and this is really no NAT. So this is going to tell the firewall not to NAT the traffic that is destined from our local subnet to our remote subnet. We don't want it to go out onto the internet, in other words, and it's weird syntax. So just follow along. If you're looking in the book, it'll be helpful, but if not, here's how to do it. NAT inside outside 1 source static net-local net-local destination static net-remote net-remote. Like I said, it's pretty weird syntax. And finally, we have to configure a default route. Now you may be thinking, gee, this is point to point. Why do we need a default route? Because if you don't do it, it won't work. Don't you love answers like that? So route outside 0, 0, 192.168.0.1 or whatever your default gateway is. Now we'll go ahead and hit enter, and in a moment we should see the ping responses come back from our partner on the other end of the connection. And there it is.